In today's lesson, we'll be looking at graphing number patterns and seeing what's the relationship between, in this case, the number of toothpicks and also the number of triangles for question 1a. So let's just examine in this pattern. In question I, we have to complete this table which relates the number of shapes. Okay, so the number of triangles in this case. So there's 1, 2 triangles and 3 triangles and so forth, and that's displayed here in the first row. With its number of toothpicks, okay? And you notice that the first row is always X, whereas the second row is Y, okay? And we've explored using tables like these before, but this time we have context, okay? We do have a situation happening. So when we have one triangle, how many toothpicks do we use? We use 3 of them, okay? You can count them as 1, 2, 3. Now, what if you have 2 triangles? Then you have 6 toothpicks here because it's 3 more than the previous one, okay? And then when you have a look at 3 triangles worth of toothpicks, well, you just add an extra 3 compared to the last set of 2 triangles, so that's going to be 9. And now without drawing 4 triangles and 5 triangles, you know that to go from one number to another, you just add 3. So you get 12 here when you add 3 to 9. Adding 3 again gives you the number 15. Now, we've got to find the formula for the table of values for question part 2, basically. So what we've got to do here is write the letter Y, and that letter has to be the second row, okay? Second row is variable. It's equal to the number it goes up by, which we said was 3. Times by the letter in the first row, which is X, okay? Then we've got to figure out what goes after that. There might be like a plus or a minus of some particular value that we've got to find out. So we do that by testing out, first of all, basically this column's values, okay? So when X is 1, Y is 3. We're just going to test that if it works or not. Okay, so that means that if I do 3 times of X, which is 1, okay, plus or minus some value, that should equal to the number 3, which is this Y value here, okay? So 3 times 1 is already 3. What do you need to add or subtract to 3 to get another 3? Well, it's just 0. Okay, so your equation is just going to be 3x plus 0, right? Which is basically y equals 3x, which means that whenever x is some particular value, you triple that value, and that will give you the bottom value here, which works, okay? Because triple 1 is 3, triple 2 is 6, triple 3 is 9, and so forth, okay? Now, what we're going to do here with this table now is we're going to graph it out. Okay, so when x is 1, y is 3. So we go right by 1 and up by 3. Okay, I'm going to put a point like that. And then right by 2 and up by 6 according to these 2 values here. Then for your next column, you've got x is 3, y is 9. So that means you go right by 3, up by 9, okay, and then you just repeat the same process. So 4, 12, and 5, 15 means 4 right, 12 up. Oops. 5, 15 means 5 right, 15 up. Okay, now notice how on the x-axis, which is this line here, I've gone up by 1. Whereas on the y-axis, you're allowed to go up by any sort of number as long as it's consistent. So in this case, I went up by 3s because it's easier for me to plot the values, okay? Because every 3 numbers is the y value there, okay? So you don't have to go up by 1 if you don't want to, because if you go up by 1, you're going to have a very long graph that is 15 units long, okay? Whereas here, I've only got 5 squares going up, each one by 3. Now, when I have a look at this, okay, these points here, it does give me a straight line if I was to join them all up, okay? So if I drew a line here, what that means is these points all lie on that line that I drew. So the points in this case, what we call them, are collinear, which means that they all lie on that same straight line. Okay? So another way of saying this also is that the relationship between x and y, okay, or the pattern between x and y, is linear. Okay, linear just means straight line. Okay, but if I had dots like this, like that, then that's not linear. Okay, so this one here is linear, the other one is not linear if it's a curve. Right, let's now have a look at the next question. Question B. Let's copy and complete the table. So for the number of shapes, x equals to 1, which is the one square, we have 4 matches. And then for the next square, or next 2 squares, sorry, we have 1, 2, 3, 4, 5, 6, 7. Okay, or you can simply see this as the first square added with 1, 2, and 3 matches. Okay, so you can basically take the number of toothpicks for 2 squares here and add another 3. Okay, and that will give you 10 by adding 3 to the 7. Now, if I keep doing that, then you have 13 and 16. So you notice a pattern here. Okay, now we're going to find a formula for the following table of values. So we write y equals to, so that comes from the letter of the second row. The number that it goes up by, which is plus 3, is going to be that first number that you write before writing x, which is the letter on the first row. Now, this has to be plus or minus by something. Okay, so we're going to test it out now. Now, we're going to test out using the first pair of values here. So when x is 1, we know y is 4, right? So if I do 3 times x, which in this case is 1, okay, plus or minus by something, so there might be some value here that we don't know of. That's supposed to equal to y, which I'll write on this side, okay? But the number that it's meant to equal to is the number 4, okay? So 3 times 1 is already 3. We've got to add another 1 to get you 4. So we'll put that positive 1 right there, so that therefore our formula is going to be y equals to 3x plus 1. And you can try that out. So this means 3 times the x value added with 1 gets the y value. So if I do 3 times 2, that's 6, plus 1 is 7. 3 times 3 is 9, plus 1 is 10. And you can test out the other two, they should work. So now that we do that, we go on to part 3, where we graph the table of values. So I've got my table of values down here. And this time, the y values here are not really multiples of a number. Okay, they do go up by 3 though. So the best way to actually draw this accurately is to actually go up by 1s. Okay, so it does use a little bit of your page. And you do that the same thing for the y-axis as well as the x-axis. So let's now graph this out. Okay, this pair of values represents x equals 1, y equals 4. So x equals 1 is 1 to the right, and y equals 4 means 4 up, like that. Okay, and then 2, 7 means 2 right, 7 up. 3, 10 means 3 right, and 10 upwards. 4, 30 means 4 right, and 13 upwards. And then 5 to the right, 16 upwards. Okay, I want you to notice also another pattern. To get from one dot to another, you just go right by 1, up by 3, 1 up by 1, up by 3, right by 1, up by 3. And if this continually happens, sooner or later, when you draw a line or a straight line that passes through the first and second, it will pass through the third, fourth, and fifth dots. So what we can say is the relationship, okay, between x and y is linear. Okay, let's have a look at the next one. Part C. So copy and complete this table for this particular pattern. We've got here 2 triangles here, okay, and we've got 1, 2, 3, 4, 5 matches that make up that first shape. Now, if we add another one of those shapes, we're basically adding on another 1, 2, 3, 4, 5. So 5 plus by 5 gives you 10. And the next one will be 15 and 20 and 25 if you add by 5. So we're now going to start using that table to find our formula. We'll use the first letter as y, which is from the second row. We say that it's equal to the number it's going up by, which is 5, times by letter here in the first row, which is x. So what this produces now is numbers that go up by 5. Okay. Now we need to have a line here to indicate it's with plus or minus by some particular value, possibly, and we test out using the first column of values. So when x is 1, y is 5. So that means 5 times x, which is 1, with some particular value here, should equal to the y value here, which we say is number 5. So 5 times 1 is already 5. All you got to do is just add a 0, and that still becomes 5. So your equation is 5x plus 0, which is going to be y plus 5x. That's the rule. So in words, this rule means 5 times the x value gives you the y value. So basically times that by 5, times that by 5, times that by 5, to all of these numbers here, and that will give you all these bottom numbers right here. All right? Okay, so next what we're going to do is we'll graph the table of values right there. So this time it's easy to graph because the y values do go up by 5. They are multiples of 5. So I'm going to graph them by drawing out 1, 5. So that's here. 2, 10, which means 2 right, 10 up, which is there. And you get the point. Okay, 3 right, 15 up. 4 right, 10, 20 up. 5 right, 25 up. And that should make you a straight line. So we can say also that the relationship between x and y are linear. Okay.